Hello, and thank you for attending my talk. My name is Katherine O'Toole, and today I will be discussing my research into musical duets on the social media platform TikTok and the impact of technical affordances on collaborative creativity in digital spaces. Digital tools and platforms have made it increasingly easy for large-scale open-source collaborations to occur by mediating interactions between users and serving as commonly accessible spaces for creative work. Music in particular is an area where technology has introduced significant changes to how collaborations can occur. The ease with which musicians can duplicate and share digital artifacts enables them to build off of one another's work and generate new musical content without requiring any coordination or direct interaction between the individual contributors, unlike traditional collaborations. In order to understand the emergence of these new collaborative practices, my research contributes a framework for analyzing collaborative creativity in digital spaces by leveraging digital trace data to examine user interactions and engagement with digital musical artifacts. To do this, I looked at examples of music collaboration occurring on the video sharing platform TikTok. In addition to being an incredibly popular and widely used platform, TikTok has a feature specifically designed to support these kinds of uncoordinated collaborative interactions called the Duet feature. The Duet feature allows a user to take an existing video and create a new version of it that includes their own content. This new child version includes the original content from the parent video, which is played alongside the new content created by the user. In order to examine how the technical affordances of the Duet feature structure collaborative interactions and shape the development of the creative artifacts being produced, we assembled a dataset of 2,173 parent-child pairs of music duet videos on TikTok through a combination of manual search and automated web scraping. Using this data, we examined the role of the Duet feature in shaping the collaborative creative process by considering how collaborative interactions are facilitated through the Duet feature and the ways in which Duet artifacts can be created, altered, and shared within the platform. First, we consider how the Duet feature enables collaborative interactions. The Duet function is designed so that any user on the platform can duet any video that is shared publicly. This open collaboration model means that anyone on the platform can contribute to the creative evolution of a video. Videos can be duetted multiple times by multiple users, and duet videos can then themselves be duetted, which allows longer duet chains to form as new contributors sequentially add additional layers of content. Because the act of duetting a video creates a new child video, we can use these relationships between the artifacts to model the interaction network by representing individual artifacts as nodes and the parent-child relationships between them as edges. Each duet chain can be traced back to one initial root video, the first video created in the chain. However, since a video can be duetted multiple times by different users, it is possible for different paths to branch off within the networks, with each containing different variations on the original artifact content. This gives users the flexibility to contribute both by adding to existing paths or by branching off and starting a new path within the network. The largest duet network from our dataset, which featured the sea shanty The Wellerman, had 180 paths and a maximum path length of 16. Most importantly, we see that there is no one final end product. Rather, the original artifact is able to branch off into multiple versions. This is different from many of the other types of online collaborations, where coordination tools are used to allow all collaborators to work on the same artifact throughout the project. Here, each version of the artifact is the result of its own distinct subset of collaborators. This porous nature of these collaborations makes it possible for the number of contributors to scale considerably and allows for ideas to be shared across a larger network of users, increasing the potential diversity and creativity that can be achieved. We next consider how we can analyze the creative development of the artifacts within these networks. In order to analyze the musical content of the videos, we can utilize music information retrieval software, which extracts quantitative information about the musical attributes that are relevant to the human listening experience and can be used to measure differences in the musical attributes of different artifact versions. In our analysis, we used a harmonic convolutional neural network created by Min Swan that predicts descriptive keywords containing high-level metadata about the audio qualities of a given music sample, such as genre, mood, the time period the song is from, and instrumentation. This model takes as input an audio sample and outputs a probability distribution across the 50 semantic tags most frequently found in the training data, showing for each tag the probability that it is applicable to the input audio. Using the probability distributions generated by the model, we can represent each video's audio content as a feature vector, which allows us to map them all to a common feature space. This allows us to quantitatively compare the similarity of the content of different artifact versions based on their distances from one another within the feature space. Here we see a 2D projection of how a path from the Wellerman tree in the previous example travels through feature space over time. We can observe how changes to the audio features are introduced with additional generations by looking at how the net distance of the path from the root node changes over time. Within a single network, we can also see that different paths branch off from one another and develop different musical characteristics, illustrated by their diverging positions within the feature space over successive generations. Because each version of an artifact exists independently of the others, the Duet feature supports parallel creative development and helps increase the amount of diversity in the artifacts being produced. If we then look at all of the artifacts within the Wellerman tree, we can see an even greater coverage of the feature space. This approach for computationally modeling the creative development of artifacts allows us to analyze large-scale collaborative creativity in terms of the collective exploration of the feature space and the degree to which different artifact paths diverge from one another over time. Next, we will examine whether we can observe consistent trends in how user interactivity varies over time. Previous studies of human interactivity, including collective attention on online platforms, have observed that the distribution of times in between interaction events tend to be heavily right-tailed and bursty, meaning that there are a large number of events with short periods of time between them and fewer events with longer periods of time in between. Within our dataset, if we look at the distribution of time passed between when a parent video was posted and when the corresponding child video was posted, we can see that this distribution is also heavily right-tailed. This suggests that duet interactivity exhibits bursty behavior, and that the social nature of duets, and the TikTok platform more broadly, plays a role in shaping how users engage in collaborative interactions via the duet feature. By examining the structural elements of collaborative interaction networks and utilizing feature vector embeddings to evaluate the creative development of artifacts, the analytical framework contributed by this resource allows us to gain insight into how digital tools can facilitate a collaborative creative process. We see with the Duet feature that the social transparency of the TikTok platform and the ability for artifacts to be developed independently of one another encourages engagement across larger collaboration networks and creates an environment which supports the creation of a diverse range of artifacts. Although these affordances are applicable to different platforms and different creative domains, this study looked solely at music collaboration. To understand digital distributed creativity more broadly, future work should also examine digital collaborations within other creative domains, such as visual art, literature, and others. Additionally, this analysis did not include social network information or success metrics such as views, likes, or the potential effect of TikTok's recommendation algorithm. Since these are factors that can influence the visibility of shared content and the motivation for users to engage with it, future work should investigate their impact on user engagement and on the development of collaboration interaction networks. I thank you very much for your time and attention, and I look forward to your questions and feedback.